Practice E, final velocity after displacement. So we're going to start with E2. It says a car traveling at initial velocity, so we're going to write our given, and we're going to write our find. A car traveling with initial velocity, so VI is equal to plus 7 meters per second. It accelerates uniformly at a rate of, so A is equal to plus 0.8 meters per second squared for a distance of 245 meters. When you're not sure what a variable is, maybe by the wording, just look at the unit. We know that velocity is meters per second. We know acceleration is meters per second squared, and displacement is meters. A, what is the velocity at the end of the acceleration? B, what is the velocity after it accelerates for 125 meters? So then I want to find VF when x is 125. C, what is the velocity after it accelerates for 67 meters? I want to find the velocity when x is equal to 67. So basically for B and C, I'm doing the same thing, except I'm just changing the x. The first thing I'm going to do is, how do I know which equation to use? Well, in the practice problems in the book, it's easy because all the problems use the same equation. Now, when I'm taking the test or I'm taking a quiz, I'm not sure which equation to use. So how do I figure that out? What I do is first I write the three that I have in my given, so VI, A, and X. Then I write the one that I want to find, which is VF. So these are the four variables that I'm dealing with. Then I'm going to look at my equations and say which equation has these four variables. So the equation that has these four is the equation VF squared is equal to VI squared plus 2AX. Now the practice problems in the book coincide with one equation at a time. So all of our equations tonight for homework are going to do this. But you still need to know how to figure out what equation to use, because on the quiz and the test, there's not going to just be one. All right, should I just plug my numbers in? No. What I'm going to do is I'm solving for VF, so I'm going to rearrange the equation to solve for the unknown in terms of the known. Why is this so important? Because when we just plug stuff in our calculators, we forget to do a mathematical function, and that's the most common mistake people make. Now, if I rearrange this, all I have to do is take the square root of both sides. So now I have VF is equal to the square root of VI squared plus 2AX. Why did I do this? Because now when I substitute in my values, you see this giant square root sign? Am I going to forget to press the square root button on my calculator after I see this giant square root sign? No. But if I left it like this and plugged in my numbers, that square root is so tiny, I might forget to take the square root at the end. So that's why I always rearrange the equation to solve for the unknown in terms of the known. What I'm also going to do is I'm going to carry my units through and cancel them to make sure they work out. Because in physics, I have a foolproof way to always check my work. So VF is equal to the square root of VI, which is going to be 7.0 meters per second squared, plus 2 times 0.8 meters per second squared, times 245 meters. That's the first one. So when I put this in my calculator, I always do it this way. So I do 245 times 0.8 equals times 2 equals plus 7 squared equals. So then I'm going to take the square root, so it comes out to be 21 meters per second. So VF is equal to 21 meters per second. But now I want to make sure that I did that right, so I'm going to carry my units. So let's look here. I have a radical. So here I have meters per second squared plus meters per second squared times a meter. Well, this is going to multiply out, so I have meter squared over times a second squared plus a meter squared over a second squared. Can I add them up now? Because they're the same. But then, don't forget, whatever mathematical function I do to the number, I do to the unit. So when I take the square root of the number, I take the square root of the unit. So the square root of meter squared per second squared is going to be a meter per second. Is that the correct unit for velocity? Yes, it is. Now, for part B, I wouldn't even bother writing all this stuff again. I know I'm using the same equation, so I would just write VF is equal to the square root of 7 squared plus 2 times 0.8 times 125, and then for C, I would do the same thing. You still need to write it out, because every time you write it, it's going to help you for the test. And then times 67. And you can do those on your calculator later. I don't have to sit here and do that for you. And don't forget, you have the answers to check on your worksheet. Okay, now we're going to jump to number 5, because there's only 6 problems for homework. And the reason I'm going to do number 5 is number 5, you might have a difficult time conceptualizing it, so I'm going to show you what to do when you need to conceptualize. So now we have E5. Remember, we're always going to write our given and our find. So it says an aircraft has a liftoff speed of 33 meters per second. So maybe I'm reading that, and I know that's a speed, but maybe I'm not sure what that 33 is. What is the minimum constant acceleration? So now I want to find the acceleration. Does this require if the aircraft is to be airborne after a takeoff run of 240 meters? So x is equal to 240 meters. So these are the only numbers that I'm given. So you know all our equations have 4 variables, and there's only 3. So I'm obviously missing something. So now it tells me the airplane wants to take off. And it tells me that it's going to go for 240 meters. You know what I'm going to do? I'm going to draw myself a little picture. And you don't have to draw it like fancy or anything. So here's my airplane. And now I know that my airplane is going to go 240 meters. And then at this point, I know it's going to take off. That's where it's going to accelerate. So now by looking at the picture, I'm going to say, well, this is where the velocity is going to be 33. And if an airplane is going on the runway, when it starts off here, this is where the velocity, VI, is equal to 0, so it's at rest. So that's what I was missing from this problem, that VI is equal to 0, because it's at rest, and then this is VF over here, because it's going to go this distance before it takes off. So sometimes just to draw a little sketch like that, it's going to help me to figure out what am I missing in this problem. Whenever you see you're missing something, try and think, like, is the initial velocity final? Is the final velocity final? Okay? So now I see I have VI, I have VF, I have X, and I want to find A. So those are my 4 variables. So I know I'm going to be using the equation VF squared is equal to VI squared plus 2AX. And what I want to solve for here is I want to solve for A. Am I just going to plug my numbers in? No. I'm going to rearrange the equation to solve for the unknown in terms of the known. So we can do it step by step. If I want to solve for A, it needs to be in the numerator all by itself on one side of the equal sign. So because there's a plus here, remember we have to know order of operations in math. We have to. So because there's a plus, I'm going to subtract this from both sides. So I'm going to say VF squared minus VI squared is equal to 2AX. Since I want to solve for A, and this is multiplied by both of those, now I'm going to divide both sides by 2x. So VF squared minus VI squared over 2x is equal to a. So now I'm going to substitute in my values. So VF is 33 meters per second squared minus the initial velocity, which is 0, divided by 2 times, oh, I'm sorry, I wrote the wrong unit here. That's just meters. 240 meters. I wrote it correctly here. I don't know why I did that. So now, when I put this in my calculator, I have 33 squared divided by 2 times 240, and it comes out to be 2.26, which will say 2.3 meters per second squared. Now, what I'm going to do is I'm going to carry my units through to check my work. Now, here I have meters squared per second squared in the numerator divided by a meter. So if you can't do it here, which you'll get in the habit of crossing it out, a meter squared over second squared divided by a meter is a meter squared times a second squared times 1 over a meter. So this meter cancels with that, and I end up with meters per second squared, which is the correct unit for velocity. But let's say I forgot, because do we all make mistakes? Yes, I make mistakes too. Like I wrote the wrong unit there when I was writing it fast. You see that squared there? A lot of people are going to forget to square that. So if you forget to square the number, you're going to forget to square the unit. So when you carry your units through to check, then you'd say, well, why isn't my unit coming out to be the correct one for acceleration, meter per second squared? Oh, I forgot about that squared there. And that's how you catch your mistake. So again, in physics, you have a foolproof way to always catch your algebra or catch, pressing a button just by carrying those units through. Now, throughout the year, you'll get in the habit when you look at the units like this, you don't have to write it out like this. You'll get in the point where you say, oh, this meter cancels with that. There's meters per second squared. Boom. And you easily check it. Okay? So that's what you need to do to be successful.